know, or probably know, that computers process everything in zeros or ones. And that's really the only way they process. And so everything that a computer processes through its CPU is either in the format of a 0 or a 1. And so that's what we mean by binary. We process everything in decimal numbers. So humans are used to decimal numbers and computers only use binary. So you have to learn this conversion so that you'll understand what's going on when you're subnetting. And I mean, there's other reasons, sometimes for permissions in Linux and whatnot, you'll need to do some conversions into binary numbers. And so it's really easy if you just look at it in a similar manner to the way we do our base 10 decimal numbers. So if you think about base 10 decimal numbers, and here, let me erase this. So when you think about base 10 decimal numbers, we have numbers 0 through 9. And those go in the ones position. And then as soon as you go up one more, so if you have the number 9 and you need to add one more to it, that moves you up into the tens position. So we have the ones and the tens and the hundreds. And it keeps going up. You know, thousands, it keeps going up this way. And so it's similar with binary, except you only have two numbers to work with. So you only have a 0 and a 1. So binary has place values as well. What I was saying is that binary numbers also have a place value system. And so here we have our binary numbers of 0 or 1. And I like to put a line through my zeros sometimes. And if we look at the place values, and we're going to go out 8 place values here. You really just use what's called the powers of 2 to determine your place value. So in this place value, we would have 2 to the power of 0, and then 2 to the power of 1, 2 to the power of 2, and so on. And 2 to the power of 7. And when you're thinking about powers of 2, all we're talking about is, let's take 2 to the power of 2, for example. This is 2 times 2. So you end up with a place value of 4 here. 2 to the power of 3, and I'll put it down here, is 2 times 2 times 2. And 2 times 2 is 4, and then times 2 more, that's 8. And so fortunately, you don't have to write that out every time you're trying to remember the place values or use this method because it just doubles. So let's look at how to double that. Okay, so if we're doubling it, and I'm going to write my place values up above here. I'm actually going to get rid of that. 0, 1, 1, 2. Oh, catch it before it gets down there. Okay. Okay, so I'm going to write my place values up above. So, like we said, in the format we're used to, which is base 10, this position would be the ones position right here. Ones, tens, hundreds, thousands. Okay, so for us in binary, we just need to remember the place values for each place. So this one's 1, And then, like I said, it just doubles. This place value is 2. This place value is 4. This place value is 8. This place value is 16. So 2 to the power of 5 is 32. So we're just doubling 16. And then if I double 32, I get 64. And that's the place value of 2 to the power of 6. And then finally we get 128 if we go 8 bits out. Okay, so you can see that, you know, if I start on the right hand side with 1, which is the place value that you need to start with, 1, then it just doubles progressively each place value that you go up. So 1, 2, 4, 8, 16, 32, 64, 128. At some point you will need to memorize this or at least be able to write it out, but for now, you know, you can just know that this is how you come up with the place values. So then if we're going to convert, so the issue is that we need to convert decimal to binary. So a decimal number to a binary number. Okay, so let's say we have the decimal number 8 and we need to convert that to binary. What you do is you just look at your place values up here and you see if there's one of them that is equal to 8. So we have a place value that's equal to 8. So we turn that bit on with a 1. Because remember, in binary, we only have 2 options. We have 0 or 1. 1 is on, 0 is off. So in this instance, we have 1, and then we don't need any other bits turned on because 8 in binary is 1, 0, 0, 0. I'll put the lines through for now, but I'm going to stop doing that because I'm going to be writing a lot of zeros. So now let's do another one real easy. Let's say we want the number 32. So we'll just turn on the 32 bit and then our binary for 32. Oh, let me put it down here. Actually, I'll just leave that one and I'll say 32 and it's 1, 0, 0, 0, 0, 0. Okay, so that's 32. All right, so now how about 33? Let's not make it too complicated. We're just going to say, all right, well, we want the binary number for 33. It's all well and good if you just turn one bit on, but how about if we have an odd number like 33? So in that case, what you do is you add your bits together. So 32, the 32 place position plus 1 is equal to 33. So 33 is going to be 1, 0, 0, 0, 0, 1. Okay, and so let's go ahead and do a few more. Why not? Okay, so let's do 128. So we'll put our zeros up here, and that's going to be, well, where do I need to have my bit on? I need to have my bit on 128. Right? Okay. At this point, usually everything's making sense for the most part, and nobody's having very much trouble converting decimal to binary. But then something comes up, like a number such as 56. So if we need to convert 56 from decimal to binary, this is where people start to get confused. So obviously there's no number 56 as an option for one of our binary place values. So you'll just pick the biggest place value that can go into 56, which is 32, and make sure and turn your 32-bit on, and then subtract 32 from 56. And you are left with 24. And so then next we'll look up here, and can 16 be subtracted from 24? Well, yes, it can. So turn your 16-bit on and then subtract 16 from 24. So we'll go the long way. 14, 8, right? 14, 13, 12, 11, 10, 9, 8. Normally if I have a live classroom, somebody correct me if I was wrong here. So now we're down to 8, and we have one 8-bit left here, and we can turn that on. So now 8 minus 8 is 0. There's nothing left to subtract. So our binary for 56, 1, 1, 1, 0, 0, 0. So there's binary for 56. We'll do this one time here for the number 255 so you can see that in action. So now the number 255 in decimal is all bits on, all 8, I shouldn't say all bits on, but all 8 bits on. And let's go ahead and go through the math. Right here, we'll erase all of these zeros. So I will give you a link to go to for a fun little game to practice binary. And I'll include that. I'll either type it over the top of our video today, or I will put it in Canvas or somewhere. So, okay, so let's take the number 255. So 255, I'm going to run out of room. I know I am, but I'll start here. So 255, and we're going to turn this bit on here, the 128, because 128 is going to go into 255. Okay, we're going to do a lot of subtraction here. Let's see, well, 4 and is that, let's see, it's going to be 7, because 8 plus 8 is 16, so 15 minus 8 is 7. 4 minus 2, we're going to have a 2, and then 2 minus 1 is 1. So we have 127. So let's take 64, 127 minus 64. 3, that's 6, so 63. So now let's take 32 and subtract it from 63. So 63 minus 32 gives us 31. So then we'll take and turn the 16-bit on. And this gives us 5. And this gives us 1. So 15, I'll start over here. We'll do 15 minus 8. And that's going to give us 7. And then minus 4 gives us 3. And then I won't do the last two, but 3 minus 2 is 1. So you have 1 left, and then you turn your 1-bit on, and that is 255. So you can see if you need to convert 255 to binary, it's going to be all 8 bits on. And the opposite of true is true. If you need to convert 8 bits into the decimal value of 255, then it'll just be, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 1, and that gets you to 255. So either way you do it, converting from binary to decimal or decimal to binary, the numbers will work. So yeah, please go ahead and try this fun little link that I'm going to list on here, and I hope this helped you to better understand and learn how to convert decimal to binary. It's a skill you will have to have going forward.